Good morning, class. This is Ma'am Renz again. Welcome to Science Time. And for today, we are going to discuss Module 3 for the second quarter, titled Shaking Things Up, Stay Alert. Now, this is again the pattern on how you are going to transfer all the answers from your module to your ISN. So please be guided. And then do not forget to upload your pictures to the album. The name is Quarter 2, Module 3, Shaking Things Up, Stay Alert. So if you have questions, do not hesitate to chat on our Facebook group on the comment section below, or chat and mention my name on our GC. For our most essential learning competency today, we have to explain how earthquake waves provide information about the interiors of the Earth. So, tungkol naman to sa ating mundo, no? Yan yung pag-aaralan natin, and how it is related to earthquake. So, diniscuss natin earthquake last time, kaya mas mabibigyan natin ng malalim na discussion yung Earth's interior. And then for our objectives, first, interpret the layers of the Earth and their characteristics in relation to seismic waves. Number 2, describe and explain the behavior of seismic waves within the layers of the Earth. 3, compare and contrast P waves or primary waves and S waves, secondary waves, in terms of their speed and behavior. And last, find the epicenter of an earthquake. Now, let's answer first our pretest. Number 1, which of the following waves travel the fastest and shake the ground in an alternative motion? A, L or love waves. B, P or primary waves. C, R or Rayleigh waves. D, S or secondary waves. Number 2, what tool is used to study seismic waves and earthquakes? A, compass. B, hygrometer. C, rain gauge. Or D, seismograph. 3, which is the largest layer of the Earth and mainly made up of oxygen, silicon, and magnesium? A, crust. B, inner core. C, mantle. And D, outer core. 4, what is the most accurate description of primary waves? A, cause more damage. B, larger waves. C, travel at higher velocity. D, travel up and down. Number 5, what do you call the vibrations in the Earth brought about by the abrupt movement of rocks? A, earthquake. B, epicenter. C, fault. D, tsunami. Now, if you are done answering, let's check your work. For number 1, the answer is B, primary waves. Number 2, it's letter D, seismograph. Number 3, the correct answer is letter C, mantle. Number 4 is letter C, travel at higher velocity. Number 5 is letter A, earthquake. Okay. So, if you can see on the next page of your module, you have to answer looking back. So, we already have experienced or witnessed earthquake. So, from here, you're going to connect through lines. So, you're going to draw lines from the first column boxes. So, descriptions yun. Then, make a line to the correct term on the second column yung mga boxes doon at the middle. And then, from the boxes at the middle, you're going to connect it to the correct drawings from the third column of the boxes. So, how to do this? Bibigyan ko kayo ng example pero mabilisan lang. Ganito yung gagawin dyan. Okay, later to. You're going to make a line. Lines pala. Ayan, charan! Oops, tama na. So, let's discuss. So, on the first column, you will see the descriptions. So, the first one, it says here, it is a disturbance that passes through a medium. That's any of the three. Pwedeng solid, liquid, or gas. Yun yung medium. And transmit energy from one place to another. That is a wave. Okay, so that's the disturbance that passes through a medium, either solid, liquid, or gas, and it transmits energy from one place to another. And this is the illustration for the wave. Next, it refers to the length and width of the moving or vibrating waves. So this is amplitude. This is the drawing. So may lapad, may tangkad. Ayan, amplitude. Next, ayan, nakikita niyo yung arrow, no? From the middle, doon sa drawing, may middle line, and then sinusukat niya yung haba, and then yung tangkad niya. Okay, doon sa may part ng arrow. So, that's amplitude. Next, third, this is the distance in a series of waves from one point to the next. This is wavelength. So, sinusukat niya yung example of compression to another compression, trough to trough, crest to crest. Yan, naaral natin yan ng physics last first quarter. So, ayan yun. So, example niyan is crest to crest. Ayan, yung isang buong mahaba na yon, that's the wavelength, yung distance na yon. Pwede din naman trough to trough, yung bandang lower part to another lower part. Next, fourth, the wave travels in a single direction up and down, and it moves in any direction. That's a transverse wave. So, remember, we have two waves, the transverse and longitudinal. So, this one, yung may up and down, is a transverse wave. Ayan siya. Yun yung may tres, graph, tres, graph. Crest yung pataas, trough yung pababa. Up, down, up, down. And then last, fifth, the wave travels back and forth and it moves in the same direction. So, that's longitudinal wave. Yun yung may rarefaction and compression. Pag nababatak, rarefaction. Pag nagkukumpulan, compression. Okay? So, this is a longitudinal wave. So, from here, you can now answer and draw lines correctly dun sa dapat nilang term and illustration. Just like this one. Okay? So, let's have now a brief introduction to the layers of the Earth and seismic waves. So, it has a big connection, yung ating earthquake, dun sa kung paano natin makikita ang layers ng Earth. Okay, so, we will travel deeper inside the Earth structure. So, just an introduction, seismic waves, behavior, and the inside of the Earth. That's our focus. Now, the Earth is made up of various components. Remember, these are the crust, the mantle, the outer core, and the inner core. Each part is further divided into more detailed parts that show its distinct features. The concept on the inside of the Earth will establish an understanding of the behavior of seismic waves. Seismic waves are vibrations after the release of energy from within the Earth. When rocks are dense, seismic waves travel easily through them, and it will even cause the change of direction. The intensity of seismic waves depends on the thickness of the Earth's layers. These earthquake waves are refracted or bent or distorted similar to the beams of light when they go through a glass crystal. Anong ibig sabihin nun? So, kaya natin na idodrawing ang interior ng Earth kahit hindi tayo nakapunta doon kasi masusunog tayo doon sa init sa interior ng Earth. Nalalaman pa rin natin kasi yung mga waves na yon, pag bumabangga sila sa solid liquid gas, nag-change sila ng direction and speed. From that, nalalaman ng mga geologists, yan, nung mga nag-aaral ng ating Earth's interior na ay may binanggaan, so solid to. Ay solid pala yung Earth's crust. And then the second one naman, nagbago yung speed. So malamang mas naging dense or pwede ding less dense. Tas idodrawing nila ulit. So mula doon nakikita natin yung kabuuang structure, no, nung ating layers ng Earth. Kaya ganun kahalaga na inaaral natin yung seismic waves in connection to the layers of the Earth. Kasi from that, nagkakaroon tayo ng accurate understanding na ito pala yung nangyayari sa crust, ito pala yung nangyayari sa mantle. Ganito pala sa inner core and outer core. So, nabibigyan natin ng justice kung bakit ganito pala yung features ng Earth, but may mga ganitong mga earthquake, ganitong mga uri ng akala natin sakuna, pero totoo pala, part pala yan ng geotectonics or process kung paano umiikot ang ating mundo. Ayan. So, nabibigyan ng linaw yung mga whys natin. So, moving on. This video will give us a background. Where is the epicenter? Remember, epicenter is above the focus. So, ang center natin nasa pinakang ilalim yan. So, hindi naman natin yan malalangoy sa gitna, no? Kasi delikado. So, yung nasa ibabaw niya is epicenter. So, pag nalocate natin yung epicenter, malolocate na rin natin kung nasan yung pinakang center or focus. So, let's watch this.
Eyewitness reports, etc. But if you want to pinpoint the actual location of the epicenter, you have to do some calculating. And so let's look at how we're going to do that. First off, in order to pinpoint the epicenter, you need a minimum of 3 seismic stations. So let's pop a few of these seismic stations on the map. Let's say we have one here in California, one up here in Canada, and one down south here, labeled 1, 2, and 3. Now, these are locations where we have seismometers actively monitoring the shaking in the Earth's crust. Of course, we have seismic stations all over the world. In order to use this triangulation method, we need at least 3 of these, or data from 3 of them. So, step 1 is going to be to take the data, the seismograms from each of these stations, and determine each of their epicenter distances. That is to say, I want to know how far point 1 is from the earthquake, how far point 2 is from the earthquake, and how far point 3 is from the earthquake. And this is fairly easily accomplished. You would simply find out the difference in arrival times for the P waves and S waves, and then use a travel time graph to calculate the distances. So let's say you have done that, and you have established that seismic station 1 is approximately 700 kilometers from the earthquake. So something like this. But the problem is, we don't know if it's 700 kilometers in this direction, in this direction, in this direction. We don't know. It could be 700 kilometers in any direction. So what we can do is draw a circle around point 1 with a radius of 700 kilometers. And now we know that the epicenter is somewhere on that circle, somewhere on that line. But again, that's not good enough because we want to pinpoint the location. So let's turn our attention to location 2. And say we did our math and we found that location 2 is 3,000 kilometers from the epicenter. Now again, it could be 3,000 kilometers in any direction. So we will draw a circle around point 2 with a radius of 3,000 kilometers. Now notice something. If you did this properly, your circles should intersect, most likely in 2 places. And what that means is that the earthquake had to happen either here at this intersection or here at this intersection. But again, that's not good enough because we want to know exactly where the epicenter was, which leads us to station 3. We take our seismogram, we do our math, and we determine that station 3 is approximately 3,500 kilometers from the epicenter. So, again, it could be in any direction, so we take a drawing compass and we draw our circle with radius 3,500 kilometers. Now, if this works out properly, all 3 circles should intersect in one single point, and that point is your epicenter.
Ayan. So, nakita natin yung process on how to locate the epicenters. So, nagkakaroon tayo ng 3 stations, no? Station 1, 2, and 3, kung saan na-detect nung ating earthquake device. And then, hindi lang dun yung natatapos. So, gagamit tayo nung tinatawag natin na triangular method. So, nagkikreate tayo ng mga circles dun sa kada stations. And then, i-intercept natin silang tatlo. Kung saan sila nag-intersect as one point, doon natin dinedeclare yung epicenter. Kung saan nag-intersect yung 3 circles. So, doon natin dinedeclare na ito yung epicenter. Kasi pag nalocate natin yung epicenter, epi means above diba? So, yung ilalim nun, nandun yung focus na sinasabi natin or the origin of earthquake. So, ganito yung process kung paano natin nilolocate. Okay. So, now, let's move forward to seismic waves. So, let's find out from this video.
Seismic activity is also one of the most important sources of information about the interior of the Earth. In this video, we're going to read about the earthquakes. So what is an earthquake? It simply means shaking of the earth. It is caused due to release of energy, which generates waves that travel in all directions. Now the question is, why does the earth shake? To understand that, you will have to look at this picture. This is a fault. A fault is a sharp break in the crustal rocks. Rocks near a fault tend to move in opposite directions. That creates friction, but at some point of time, their movements overcome the friction. As a result, they slide past one another. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called the focus of an earthquake, or there is also a term given to it called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface nearest to the focus is called epicenter. This place is the first one to experience the waves. All natural earthquakes take place in the lithosphere. The lithosphere refers to the portion of depth up to 200 km from the surface of the earth. An instrument called seismograph records the wave reaching the surface. The waves look something like this. The curve shows 3 distinct sections, each representing different types of wave patterns. We'll get back to this pattern in a moment. Earthquake waves are basically of 2 types, body waves and surface waves. I need you to understand the term body waves. Sounds a little larger within the body, right? So the body waves are generated due to the release of energy at the focus, that is the epicenter, and moves in all direction, traveling through the body of the earth. You know, it travels internally within the earth's surface and moves the interior of the earth. That's why it is referred to as body waves, because it is traveling through the body of the earth.
Ayan. So, nakita natin from the simple video, no, the different layers of the earth. So, nakikita natin kung paano sila nag-travel dun sa surface and hanggang sa interior. Nakikita natin meron tayong body waves, yung nagta-travel hanggang pinakanloob. And then the surface wave, yung sa outer lang, no. Then from that, nakukuha na natin na ito pala yung layer ng earth, hanggang dito lang kasi yung wave, so maybe ito yung part na to. Then another part naman kapag tumagos siya dun sa pinakang loob. So, ayun siya. So, nakikita natin yung hypocenter. Hypocenter is known as the focus or the origin, no? Ayun siya. And then epicenter yung nandun sa taas niya, just above the center. So, next. Yan. So, this is the illustration of the earth in accordance of the waves that travels within or within the earth or within the surface lang, no? So, nakikita natin, kung ang epicenter ay nasa above ng surface ng earth, nakikita natin yung mga waves niya, no? Hindi natin nakikita, pero dito sa illustration, pinapakita niya, no? Remember that P waves or the primary waves is the color yellow, and then the black, yung mga arrows sa black, is the secondary waves. So, makikita natin dito, doon sa mga layers na may combination ng black arrow and yellow arrow, ang nagta-travel lang sa area na yon ay the primary and secondary waves. But pagdating na dun sa susunod na layer niya, no, ng circle, so ito yung yung nag-iiba na nagbe-bend, nakikita natin habang papalalim ng palalamin yung layers, no? Nag-iiba siya ng direction, nagbe-bend siya, and then yung iba naman lumilihis lang. Yan. So dito natin masasabi na may iba't ibang layers nga ang ating earth, and at the same time nalalaman natin kung solid ba siya, liquid or semi-liquid yung mga parts ng earth. So let's discuss now the 3 layers of the earth. So the first one is the crust. Crust is the thinnest and outermost layer of the earth. It is subdivided into 2 regions, the continental and the oceanic. So, yung lupa na tinatapakan natin ngayon, yun ang continental, and then yung lupa dun sa part ng dagat, ang tawag doon ay oceanic. So, akala natin napuputol yung lupa, no? Hindi po. Nalalagyan lang siya ng tubig, no? Kaya siya, akala natin napuputol. Pero totoo, tuloy-tuloy yun. Next, the upper layer is composed of granite and is found only in the continental crust. So, yun yung pinagkaiba ng continental and oceanic, kasi sa continental lang may granite. Below granite is a layer of basalt. Yan. So, pag kinalkal mo yung granite, makikita mo naman sa ilalim nun mga basalt. This is found both under the continental and oceanic crust. So, parehas ng merong basalt sa continental and oceanic crust natin. Next, features of continental. First, made up of silicon, oxygen, aluminum, sodium, potassium. Ayan siya. Thickness, kung gaano siya kakapal, 35 to 40 kilometers. Found under land masses are less dense rocks such as granite. So, nabanggit na natin kanina na may granite sa continental. Doon lang siya makikita. Sa oceanic, walang granite. While the features of oceanic, it is around 7 to 10 kilometers thick. So, mas makapal yung continental pala, no, kaysa sa oceanic. It is found under the ocean floor, made up of dense rocks such as basalt. So, yung oceanic, kaya siya pumailalim kasi mas siksik or much denser. Okay, yung medyo less dense, pumapaibabaw. Ayun yung natatapakan natin na lupa, yung continental. So, that's the features of the Earth's crust. Next, merong boundary na nagahati bago tayo makarating ng mantle. So, ang tawag doon, crust-mantle boundary. So, this is called Mohorovičić discontinuity. It is the boundary between crust and mantle. In honor of Yugoslavian seismologist Andrija Mohorovičić. Ayan, short term for MOHO. Ayan, yun yung term. Next naman natin is the mantle. Now, beneath the crust is the mantle. So, ito na yung medyo inner sa crust, which extends about 2,900 kilometers. So, mas makapal to kesa sa crust. It makes up of 80% of the Earth's total volume and 68% of its total mass. Ayan. So, malaki-laki pala, no? It is mainly made up of silicate rocks. The mantle is made up of elements silicon, oxygen, iron, and magnesium. So, ganun yung mga matatagpuan natin sa mantle. The lower part of the mantle consists of more iron than the upper part. So, pag bandang ilalim na ng mantle, mas marami na pala tayong iron na makukuha doon. The temperature and pressure increases with depth. So, mas nagiging mataas o mas mainit. Okay? At mas mataas din o malakas ang pressure kapag pumapailalim na tayo ng husto dito sa layer na to. The high temperature and pressure in the mantle allow solid rock to flow slowly. So, nagiging solid na yung rock, kaya yung fluidity niya bumabagal. Kasi solid na yun, di ba? Ang boundary naman ng mantle bago mag-core, yung pinakailalim na yung core, ang tawag doon ay Gutenberg discontinuity or the mantle core boundary. Bakit Gutenberg? Kasi in honor of the German seismologist named Benno Gutenberg. So, yun yung naka-discover nun. Okay? So, that is all for the mantle description. Next naman natin is the core. Ayan. Core description. It is subdivided into two layers. The inner core and outer core. The outer core, yung labas, is 2,900 kilometers below the Earth's surface. Na ganun na siya kalalim. Outer core is 2,250 kilometers thick. So, mas makapal si outer core kesa kay inner core. It's made up of iron and nickel. So, dun na pala yung source ng mga iron and nickel natin, no? Kaya pag nagkakaroon ng mga earthquake, ayan, tapos lumalabas yung mga iron and nickel dito, natatagpuan natin siya sa crust. The temperature of the outer core reaches up to 2,000 degrees Celsius, so mainit talaga. At this very high temperature, iron and nickel melt. So, natutunaw, no, liquid na pala siya. Outer core is made up of iron and nickel moving around the solid inner core. So, yung outer core, liquid. Pero yung inner core, yung pinakang loob na, ay solid. So, creating Earth's magnetism. So, yun na yung sense ng inner core. Nagkikreate siya ng magnetism. Features of inner core, ito na. Made up of solid iron and nickel naman. So, kanina, melted iron and nickel yung outer core. Pero yung inner core naman, solid iron and nickel. And meron siyang radius na 1,300 kilometers. Now, it was predicted by a Danish seismologist named Inge, I don't know if it's Inge or Inge Lehmann. Ayan. Its temperature reaches about 5,000 degrees Celsius. Sobrang taas na niya kaysa sa outer core, no? Yung extreme temperature na to, dapat molten iron and nickel na. I mean, molten iron and nickel. Pero, mabilis siya nagsosolidify, kaya, para siyang, nafi-freeze na. No? May melt siya, pero nagsosolid din agad. So, common yon na nagiging ganon, kapag sobrang na yung pressure at sobrang init. Kaya, yun yung nag-e-explain kung bakit yung inner core natin ay solid kesa dun sa outer core. So, ganun pala yung beauty na nangyayari sa inner core natin, na sa sobrang pressure, sa sobrang init, yon, nagsosolidify siya. So, parang puso natin, no? Pag sobra-sobra na, no, nasaktan, tumitigas. Oh, char. Na-relate pa ni mami, no? So, yun yung ating core description. Okay, now let's watch another video regarding earthquakes and seismic waves. Okay, so very well detailed yung video na nakita natin. Pinapakita dito yung iba't ibang uri ng waves, and then at the same time, kung paano sila gumagalaw sa ilalim ng lupa at sa ibabaw ng lupa. And then, meron din tayo ditong tatlong uri ng soil, yung solid bedrock, loose sediment, and sand and mud. Pinapakita to kasi iba't iba yung intensity or impact na binibigay ng different kinds of waves. So, yung pinaka great impact niya ay doon sa sand and mud kasi mas loose na no? Hindi tulad dun sa solid bedrock, yung mga rocks under na kinakapitan ng soil ay malakas pa yung kapit or friction. At the same time, nakaka-apekto din yung uri ng materials dun sa buildings, structures, even kahit residential, no, yung mga bahay natin, nakaka-apekto yung mga materials na ginamit natin para maging prepared tayo dun sa impact ng earthquake. And however, kahit na ano pa yung structures na tinatayo natin, yung kung paano gumagalaw yung iba't ibang uri ng waves natin, hindi yun nagbabago. No? Pero ang sinasabi lang dito sa video, maganda na napaghahandaan natin yung earthquake at kung paano sila gumagalaw, kung gaano kabilis, gaano kabagal, kung paano sila nag-change na in direction. Yan, lahat ng yon ay pwede nating ma-predict kasi naaaral na natin siya ngayon. Etong liquefaction na sinabi dito sa huling video, ito yung process na kung saan yung sediment naglo-lose ng strength. Tapos nag-act siya as a liquid. No? Kasi bumibigay siya Yung ilalim ng lupa mismo, yung nagkaka-problem. Kaya kahit anong ganda ng structure sa ibabaw, nasisira. Kasi nagkakaroon ng liquefaction due to earthquake shaking. So, di natin nakikita, may nangyayari na pala dun sa ilalim ng lupa, no? Kaya, mas best kapag solid yung bedrock. Di naman sinasabi na walang damage na magaganap doon. Siyempre, meron pa rin. Pero kung talagang yung components ng lupa mo, nawawala yung strength o yung kapit ng mga solid rocks doon, ayun, magkakaroon talaga ng malaking damage. So, let's move on to this illustration. So, meron tayo ditong legend. Yung red na arrow, yun yung mga primary waves or P waves. And then yung blue na arrows, yun yung secondary waves. And then yung yellow arrows, those are the surface waves. So, nakikita natin kung paano siya tumatama sa iba't ibang interiors ng Earth. Ayan. So, dito natin nape-predict ngayon na ay solid pala yung ibabaw. And then, yung mga inner layers niya or combinations of solid and liquid. Some are semi-solid. No? Kasi nga, nag-iiba-iba ng direction and speed yung ating mga iba't ibang uri ng waves. Ayan. So, punta tayo dito sa seismic waves. So, let's talk about this. When we say seismic waves, these are the mechanical vibrations that occur inside the earth along fault lines, which is caused by the breakage of rocks. So, inaral natin na nakaraan, no, may iba't ibang uri ng paggalaw yung lupa, no, due to the stress. Pwede siyang dahil sa tension or naghiwalay yung lupa. And then, meron din tayong due to compression, yung nagbanggaan yung lupa. Pwede din naman nag-slip side by side, no. So, from this stress, nagkakaroon ng crack. So, nagva-vibrate yung lupa. So, nagre-release siya ng energy in a form of seismic waves. So, nagkakaroon ng crack or fault, no? And then, yung ibabaw ng lupa may guhit, yun yung fault line. So, the waves that transmit energy released by the earthquake are called seismic waves. So, yun yung waves na tinutukoy doon. So, we have two kinds of waves, the surface waves and the body waves. So, surface means sa ibabaw lang siya, and then body waves hanggang ilalim. So, we have two kinds, the primary waves or the P waves, and then the secondary waves or S waves. So, P waves or the primary waves, these are more powerful and fastest kind of wave than the secondary. Siya yung una, kaya nga primary at pinakamabilis. Longitudinal yung uri ng wave niya, meaning may rarefaction, compression. And then, primary waves can travel to solid rocks, even liquid and gas, no? Hindi tulad ng secondary wave. Yung secondary wave, less powerful siya than the primary waves and mabagal. Ang uri ng wave niya is transverse, yun yung may up-down, yung crest, trough. And then, ang natatravel lang niya na part ay yung solid rocks, pero hindi na niya kayang tumagos sa fluids, sa liquid and gas na part. Hindi na, dun lang siya sa solid. Kaya nga siya secondary. So, pangalawa siya na nagtatravel doon sa primary wave. And then, the surface waves naman, ito yung example niya. L waves are the love waves and the Rayleigh waves. So, when we say Rayleigh waves, they travel along freely on Earth's surface. Movement is a combination of longitudinal and compression. So, ito yung paikot-ikot. Pero yung love wave, it travel along the Earth's crust directly above the epicenter. So, dangerous to kasi mismong sa epicenter siya lumalabas. Kaya nga, it causes ripples on surface that is the most damaging type. So, ano itsura nun? Ito yon. So, yung dalawang nasa taas, primary and secondary waves, ito lang yung motion niya. Yung P waves, longitudinal, no? So, back and forth motion lang. Yung S waves naman, up, down, transverse wave siya. So, nagtatravel sila hanggang sa Earth's interior. Pero yung surface waves, mas damage yung effect niya kaysa sa body waves kasi andun yung love waves. So, kung makikita niyo yung love waves, umiikot na siya, then nagsa-side by side pa siya. Kaya napaka-destructive niya. Yung Rayleigh waves naman, destructive din, kasi paikot naman siya, no? Pero yung love wave, tingnan nyo, umikot na, nag-side by side pa. So, talagang sira yung structure kung saan matatamaan niya. No? Kasi nga, directly siya doon sa epicenter. And remember, L waves and Rayleigh waves are examples of surface waves, no? Sa ibabaw lang siya, pero talagang yung effect niya, ganyan. Ayun. So, let's move on now to the activities. So, masasagutan nyo na yung activity natin. Activity 1, name that fruity layer. So, dito, i-compare lang natin yung Earth's interior sa laman loob ng isang kiwi fruit. Then, sagutan nyo yung tabular data doon kung anong part ng kiwi fruit yung maihahalin tulad sa crust, mantle, inner, and outer core. And then, yung mga descriptions ng crust, mantle, outer, and inner core nandito sa baba, sa number 2. Sasalpak nyo lang yung mga choices dun sa correct column. And then, answer the guide questions 1 to 3. For activity 2.1, finding out the seismic way. So, meron tayo ditong puzzle. Encircle nyo lang yung mga hinahanap na term, no? And then, sa part B naman, yan, na-discuss natin to kanina. Ito yung mga parts ng ating interior ng Earth na kung saan solid siya, semi-solid, solid and liquid. Ayan. Then, answer the questions 1 to 3. For activity 2.2 naman, comparing two body waves, ito na yung, na-discuss naman na natin to kanina and napanood nyo din dun sa video, yung primary wave and secondary wave, no? Sagutan nyo lang yung table below. You can go back to the slides dun sa summary natin and dun sa video para kung gusto nyong tingnan ulit, no? Then, part B, yan, nakita natin na P wave is longitudinal wave. It can travel sa solid. And then, the secondary wave naman is nagta-travel siya kaya mag-travel sa liquid. Ganyan yung itsura niya, no? And then, transverse wave siya. And then, answer the questions below 1 to 3. For activity number 3 naman, spotting an epicenter. Ayan, napakita natin dun sa early videos natin kung paano mag-spot ng epicenter using triangular method, no? So, just follow the procedures and then yung complete the tabular data and plot the 3 spots for the earthquake dito sa number 5, no? Yan, so gagamit tayo ng compass para malocate natin yung epicenter. So, do not forget that seismic waves are shaking energy generated by the abrupt breaking of rocks inside the earth. Abrupt means mabilisan. And seismic waves also vary in intensity. Yun yung effect or damaging effect sa infrastructure and lives of people. And also vary in direction at different points within the earth. So, nakita natin yun kanina, no? Nagtatravel yung seismic waves. Depende kung solid, liquid, or gas siya. Nag-iiba din ang direction and speed. So, through these changes, scientists succeeded in mapping the Earth's interior. So, yung drawing na nakikita natin kanina, ang tawag doon, mapping the Earth's interior. The Earth has limited changes within. Seismic waves are refracted at their maximum and return to the surface. So, may iba't ibang behavior tayo na seismic waves. And then, meron tayong primary wave, which is the fastest type of seismic wave. It hits a seismic station first. So, yun yung una na detect na seismograph natin. It passes easily through solids or liquids. Unlike secondary wave, is slower type of seismic wave. Contrasted with the primary waves, it can travel to solids but not through a fluid medium. So, yun yung pinagkaiba nilang dalawa. So, let's answer now the post test. Number 1, earthquakes are the rough shaking of the Earth's blank. A, crust. B, inner core. C, mantle. D, outer core. Number 2, it is the position on the surface of the Earth where the pressure is released. A, epicenter. B, fault. C, focus. D, plane. Number 3, it is a seismic wave that passes through the interior of the Earth. A, body wave. B, surface wave. C, radio wave. D, infrared wave. 4. During an earthquake, it produces the most damaging occurrence. A, love wave. B, Rayleigh wave. C, primary wave. D, secondary wave. Number 5. It is the shaking of the Earth's surface as a result of the rapid release of energy in the lithosphere. A, earthquake. B, fault. C, epicenter. And D, tsunami. So, if you are true, let's check. Number 1 is letter A, crust. Number 2, A, epicenter. 3, A, body wave. 4, A, love wave. 5, it's A again, earthquake. So, that's the correct answers from 1 to 5, all letter A. And then last, for the reflection, are you ready for the wave? So, dito, mag-drawing na lang kayo ng interior ng isang simpleng bahay, just like the one illustrated here. And then, i-position nyo yung tall furniture, hanging lights, computers, mirrors, pictures, gas appliances, dun sa dinrawing nyo. So, kayo bahala kung saan nyo ilalagay siya. And then, sa number 3, isusulat nyo yung mga possible ways to protect these things kung sakali nagkaroon ng earthquake. Kasi may times sa pag nag-earthquake, tapos mali tayo ng mga position sa mga appliances natin, nagkakaroon ng accident. Minsan, pag mali yung position ng gas stove natin, sumasabog siya, nagkakaroon ng fire. So, may earthquake na, may sunog pa, di ba? So, ayun. And then, you answer the questions 1 to 3 below. And then, wait for the further announcement for the output number 2, which is also graded. Intayin nyo na lang i-post ang teacher nyo and sabihin sa GCs. So, ayun lang. I hope you learned something from our lesson for today about Earth's interior in relation to the different kinds of seismic waves. Good day and goodbye.